In today's lesson dealing with fractions, we're going to review the basics of adding fractions. And to keep things simple for today, we will leave our fractions as having the same signs. So we'll either be adding two positive fractions, as you see in the first example, or adding two negative fractions, as you see in the second example. Now remember, it doesn't matter that we have fractions here. These are just two numbers that have the same signs. So the rules that we learned earlier with integers still apply. And even if these were decimals, same sign numbers, we'll just add together, keep the sign. As fractions, same sign numbers, we'll just add and keep the sign. Just like with integers, same sign numbers, we'll add and just keep the sign. So what we need to do is move on otherwise to what the rules are for adding fractions. So you've done enough practice with fractions in years leading up to this year. So you should recall that first you need to convert your fractions to common denominators. And then as needed, or then when you're ready, you will add the numerators. If it's a mixed number, you'll add the integers. So this is really in the event that you have mixed numbers. Okay, so you add the numerators of your fractions, and then you add the integers made up of your mixed numbers. So that's only if it's mixed numbers. So that may or may not apply. If we have a mixed number answer, we might get a funny looking mixed number where the fraction piece is improper. So we're going to have to deal with that as well. So we'll see if that comes across. And then always take a last look at your answer to see if it's necessary to reduce. So let's start with this first problem, 7/8 plus 1/2. I always like to start by rewriting the problem in a vertical manner. So I'm going to say 7/8 plus 1/2, like so. My first number becomes my top number. My second number becomes my bottom number. So the next thing we're going to need to do is to convert these fractions to having a common denominator, because you notice the denominator currently is 8 and 2. Now this is where our work with least common multiples is going to come in handy, because we need to know essentially what the least common multiple of 8 and 2 is. So hopefully we can, in this case, do that in our head. So least common multiple of 8 and 2 would be 8. So that's going to make life a little bit easy for me when I deal with converting 7/8, because that's just going to stay as is. But for the 2, I have to ask myself, what do I multiply 2 by to give me 8? So let's see. This is misbehaving for me. So my 7/8 will stay the same, but down at the half, 2 times what is 8? 2 times 4 is 8. And to keep this an equivalent fraction, I'll have to do the numerator. 1 times 4 is 4. So we're now looking at 7/8 plus 1/2, written with common denominators being 7/8 plus 4/8. So we've taken care of that first step. The next thing we're going to do is to add the numerators. So my numerator in the first fraction is 7, and in the second fraction is 4. So we're going to add those together. So 7 plus 4 is going to give me 11. Is going to give me 11. And if there were integers, if these were mixed numbers, if there were integers, I would have to add those as well. But I don't need to worry about that in this case. So I've added my numerators. There's nothing to do here. And then I carry my denominator down. I didn't really say that, but we just need to make sure that we added 7/8, we added 4/8. That gives us 11/8. We do need to move on now to the next step, because right now this is an example of an improper fraction, and I want to turn it into a mixed number. Now remember, that's just a matter of asking how many times does the numerator of 8 go into the denominator of 11. So the 8 goes into 11 one time, and we know 8 times 1 is 8. How much is left over as a remainder to get me to 11? Well, there would be 3/8 left over. So I've taken care of adjusting for the mixed number. And then I take one last look to see if my fraction still needs any reducing. And 1 3/8 looks like it's fully reduced already. So 7/8 plus 1/2 gives me a final answer of 1 3/8. So that should all be pretty familiar to you, but I just wanted to walk through that example. So now let's move on to the next problem. It's negative fractions, but again, it's two negatives, so we will just add them and move on. So the first thing I always like to do is to rewrite my problem vertically, negative 2 1/6 plus negative 5 3/4. Now remember, we're going to have a negative answer, so I'll just make note that by the time I'm done, my answer is going to be a negative answer. So first things first, I need to get these converted over to being common denominators. So I'm going to have, and I'm going to ignore my signs from here out because I already got my sign taken care of there, okay? So we're going to have 2 and, well, what's the least common multiple or the least common denominator of 6 and 4? That would be 12. So it's going to be 2 and some number of 12ths plus 5 and some number of 12ths as well. So I'll need to now ask myself, 6 times what is 12? 6 times 2 is 12. So 1 times 2 will give me a 2 for that numerator. So 2 1/6 is equivalent to 2 and 2/12. I'll do the same for the other fraction. 4 times what is 12? 4 times 3 is 12. So to keep this equivalent, 3 times 3, 3/4 will turn into 9/12. So we converted to our common denominators. Now we find the equivalent fractions and we're ready to add our numerators. So the next thing we'll do is we're going to add 2 plus 9. Should give me 11. Don't forget the denominator stays the same, so 2 12ths plus 9/12 is 11/12. And here is where I need to add my integers. So I need to add these the integer values, the 2 and the 5. And 2 plus 5 is going to give me 7. So I look one more time. Is that a normal looking mixed number? Yes, it is. So 7 and 11/12. It's not like there's too many in the numerator that I need to carry over. So our final answer, since it's fully reduced, would be negative. Don't forget it was two negatives being added. Negative 7 and 11/12 is the answer to negative 2 1/6 plus negative 5 and 3/4. So that should be what I hope to be a very familiar and very quick review for adding fractions. If you have any questions, we'll check in class tomorrow.